Hey there, everyone. My name is Ryan Schul. Welcome back to my channel. So today I want to talk about clustering based on consumer spending behavior. So I thought about this topic kind of recently. I put together some ideas and wrote some code. I want to take you through it right now. And by the way, I'll just preface this by saying this is my next to last video before getting to 365. I started this journey on August 8th, 2024, and I came up with some arbitrary random thing that I said I was going to produce one YouTube video every day for 1 year, and then try to hit that target. So that's what I did. I'm going to put out one more video a little bit later today, and that'll be number 365. So I got over the finish line just in time with a couple of days to spare, and I think I'll keep on putting out some videos, but at a much slower pace. I have to look at getting back to the corporate space. I left corporate America a little over a year ago, started this YouTube journey, and it's been fantastic. I learned a ton, made absolutely no money, didn't even get one single penny from YouTube, and that's fine. I think I have to go back to work and start making some money here, but I learned a ton. I think it was a great experience and just as valuable as any kind of education from any top school, Ivy League or otherwise. So that's that. So yes, this is clustering based on consumer spending behavior. And why would we even be interested in doing this kind of analysis? Basically, to identify similar or maybe dissimilar customer markets. Use case could be retail companies expanding into new stores or new states, and how can we target customers that behave like customers in known markets where you've operated before. So if you're expanding and growing your business, that's great. By all means, go for it, either naturally organic growth or through acquisition, M&A, something like that. That's fantastic. But I think it's a good idea to understand your fundamental base customer set, right? The foundation customers that you have built up, understand how that works, and then transfer that into the new market and do the clustering based on that, right? I think that makes a lot of sense. If you just do it randomly, I don't know what the outcome is going to be. So yeah, you have that. I was going to tell a quick story, but I'll just I won't tell the story. That's kind of like meaningless. Anyways, so we can enable targeted marketing and personalization for these new customers that we're going to be working with in the new markets that we enter. We can detect economic stress or resilience or resistance too, right? We can support strategic policy designs. That's pretty easy to do based on these clustering techniques I'm going to show you in just a minute. We can overall simplify complex data sets into very meaningful data that has a purpose, that has an influence, that has a substantial results. We can have a substantial impact on the customers that we interact with. And this can overall help us to guide investment and expansion decision making, right? So the business can prioritize high growth customer markets, avoid regions showing low or declining customer activity. We'll steer away from that. And a good use case could be a furniture retailer could cluster based on durable goods spending and find promising launch states rather than expanding into every state. Where does it really make sense to be based on other states that you've already operated in, and do the consumer spending behaviors of some new states match with these existing states? Then by all means expand. If it doesn't make sense, then don't do it, guys. Don't do it, okay? So that's the basis for the analysis for today. So I have this Excel file that I'm working with, all right? It's saved on my desktop. I am going to go to a specific sheet in this Excel file. Excel can have a bunch of different worksheets, right? A CSV file is basically just a text file. It can only have one worksheet. Excel can have many worksheets. We're going to use columns A through J. I'm going to skip the first 3 rows, and I'm going to expand 60 rows below that. So I'll show you this data. It comes kind of funky. That's why I have to set up like a couple little guidelines or rules. I have to put these guardrails in place so Python knows what to do to extract the data correctly. This is what the file looks like. So we have a title over here in cell A1. This is actually A1. You can tell that they've merged these cells. Working with merged cells in Excel is the bane of existence for any Excel person or any Python person, but people do it anyways, right? They don't really care. So if I go over here to alignment, merge cells, and unmerge this, you can see this really goes from A1 to J1, right? But they have merged these 10 cells into one. So if I could do Control Z to undo that, it's really a merged cell. So these merged cells are kind of difficult to deal with, but there's ways of handling that. I'll show you in just a second what I'm doing here. This is merged cells. These are merged cells. You can see this is 3 and 4. It always goes to the top left of the cell, right? So it actually calls this A3, but this actually is 2 cells merged together. So this is A3 and A4 merge into one cell. This is B3 and B4 merge into one cell. This is B3, it goes to the upper left-hand corner. This is J4, so this is actually not a merged cell, but these are merged, these are merged, these are merged. So it's kind of tricky to deal with this stuff, but it's certainly not impossible, and we can handle it pretty effortlessly, right? But we do have to set these rules or these guidelines right here. So we have to go to sheet name, look for A to J, start in row 3, and get the next 60 rows. And then because we can't really get these titles that you see here, because these are merged cells, we have one merged cell and then several non-merged cells. We have to handle this manually. So I have state, PCE, and then these titles over here. So if I hit Control Enter, you'll see what this looks like. Go to the desktop, fetch the data, and bring it back into a data frame. Okay, so I'm dropping state from the data frame, and I'm setting the index as the data frame over here. So state comes in state, total PCE, durable motor vehicles, durable furnishings, durable recreation. So we have that, durable other. Then we have some non-durable categories, non-durable food, beverage, non-durable clothing, non-durable gas, energy, non-durable other. Okay, so if you go back to the data source, this is what it looks like. Okay, non-durable other. Because these are coming from non-durable goods, this is the merged cell. These are the durables, right? And we have total PCE and percent change ending by state, and we have all the state data down here. So if we look at the first few cells, we have 646666, and that's what we should see over here, 646666. Okay, and on the end we have 657496 down here. The first 5, 1, 2, 3, 4, 5, 6, 5, 7, 4, 9, 6. So that's that right there. And then on the lower left-hand side, we see Nevada, Oregon, Washington, 595464, 595464, Nevada, Oregon, Washington, right? And if we go to the right, we have ending 665267. Okay, hopefully you see that. 665267. So just quick sanity check just to make sure everything's working, and I believe it's working, so we can proceed. So I'm going to go ahead and just do one more quick sanity check. Do we have any merged cells here? I know that we do. We can prove that right here. This is NaN, not a number. NaN, not a number. This is total PCE by state, and then NaN. So NaNs are bad. We have to get rid of those. Total PC by state. And NaN, because again, these are merged cells. So there's nothing here, there's nothing here, but B3 has data, but B4 does not, right? So that's why we have total PCE by state and NaN. So just a way for, peace of mind, quick sanity check or whatever, just to make sure everything's working, okay? And I believe it is. So we're gonna set up our first clustering exercise right here. We're gonna scale all the data. So this takes anything that's an outlier or that's an anomaly and something that's very extreme, high or low on different ends of the spectrum, and consolidate everything so we can make these comparisons relative to everything else. Now we're going to look at things that are very similar and put those into the same cluster, and things that are somewhat similar but somewhat disparate or somewhat different, those go into separate and distinct clusters. Okay, so I have a few videos on my channel now about how to do clustering. You can check those out. I think this is very interesting. This is one of my favorite things in the whole data science world. I like regression, I like classification, I like deep learning, AI, all these things, but actually my favorite thing of all is clustering. I think it's very interesting how things that are homogeneous get pulled into the same cluster based on the differences or the mathematical subtractions between different clustering points, right? If it's minimal difference, those go into one cluster. If it's heterogeneous and very different, those go into their own separate cluster, but everything in that cluster is homogeneous, right? So everything is either homogeneous in the same cluster or heterogeneous in different clusters, But among all those different clusters, there are things that are homogeneous and those go into their own clusters, right? So very interesting concept, very cool, I think. That's what I think. So I'm going ahead and dropping state from this data frame. I'm scaling all the data, right? So I'm excluding these right here because I don't want to look at United States, New England, Mideast, Great Lakes, and so on and so forth, because those have been pre-aggregated over here. If you look at United States, New England, they're basically taking an average of all these others over here, right? So how are they getting an average of 6.6? I can see average 6.5. This is a rounding error, I think, something like that. But the average for these states right here are 6.6. For the Mideast, it is 6.4. Again, I think the rounding is off just a bit. But they have these, the main group is the United States, 6.4. Then they have these subgroups, these regions, which is okay. I kind of want to avoid that because I don't want to double count these things. So I'm going to exclude anything that's not an actual state, okay, just for my analysis. But you could include it. It really depends on what you're trying to accomplish here. I want to exclude these and ignore these just for my analysis. So I'm going to kind of kick those out and say everything that's excluded, Control F if I search for this, is in excluded with this little squiggly, this is called a tilde character. This means not. So anything that's not in this data frame, in this column called state, that's in this excluded list is in, but not, right? That's what the tilde key does. So it's a little bit, the first time I saw this, I was like, what is going on here? But you have to understand that logic, right? So is in is included, but not is in is excluded, right? So based on that, I can go ahead and do my K-means clustering. I set 4 as my number of clusters. Here's the K-means. And I'm appending that as a new column onto the data frame. So I have df states. If you look closely, Control F, Control, wait, I didn't get that right. I got that. Got too much here. Okay. Df states. That should be right. Let me see. Yeah, df states. So anything, again, that's is in excluded, but not in, right? That gets into this data frame, and this data frame originally comes from over here, or df gets converted where, oh yeah, we're taking a copy of that, okay? So we copy everything into df states, so we get the states. Then we can see the new column that's appended over here. So here's our clusters. So based on K-means clustering, everything is assigned a value from 0 to 4, or 0 to 3. Sorry. So Python is 0 based, so we have 4 clusters, 0, 1, 2, and 3. Those are the 4 clusters, but 0 based. So you always start with 0. Excel is 1 based, and a lot of databases are 1 based, so you start with 1. In the Python world, you start with 0. So I'm pulling in the information. I got my clustering done right there. I think that's pretty cool. Okay, so we accomplished that. Now let's look at a different type of clustering. DBSCAN, which is density-based scanning, and agglomerative clustering. So it's about 7 or 8 different types of clustering techniques. You can experiment with different ones. I'll leave that up to you to decide. Let me do a quick Google search. How many clustering algos in scikit-learn? Probably 8 or 9, I think. Oh, they have 12 to 13 now. So they've increased it a little bit. These are the main ones. K-means, that's what we're doing. Affinity propagation, we're doing that. DBSCAN, there's something called optics, Birch, bisecting K-means, Gaussian mixture, agglomeration, that's a new one. I haven't even heard of that. And then spectral biclustering. I think I've heard of that. I haven't used that. So anyways, there's about a dozen or so that you can test out. I'm looking at 3 in this case. So I'm pulling in the data again, setting the columns, excluding some, and then I'm going to go ahead and apply the K-means, DBSCAN, and agglomerative clustering all together in this case. So the first time I just did K-means, pretty simple, pretty straightforward. Now I'm going to do all 3. So we have the K-means cluster, DBSCAN cluster, and agglomerative cluster. And I want to go ahead and plot these using Plotly. So we can use this technique called a choropleth map. It's very cool. You take everything and pop that into a map format. So you can see visually, based on the United States geographical map, how everything plays out. You do have to use state abbreviations like this: AL for Alabama, AK for Alaska, AZ for Arizona, WY for Wyoming, Wisconsin, so on and so forth. So we don't have the state abbreviations. We have straight state names. So we have to create a convention or some type of construct here where we are mapping the state names to the state abbreviation using a dictionary technique. So anything in curly braces is dictionary, and you can see a key and a value here. So this is a key on the left side of the colon, and everything typically is in quotes, at least if it's text. If it's numbers, and it's not in quotes. But here we have the mapping. So based on this, we can create the KMeans clustering, DBSCAN clustering, Agglomerative clustering, and the state abbreviation, and do the mapping based on Plotly's ability to visually map all of these. But again, it has to be in the state abbreviation, not the state name. So we have to use the two-letter character to get the clustering, to get the mapping done. Okay, so we have the map right here. This looks nice. And we can see what the K-means when we zoom in here. Actually, let me see if I can increase the size of this just a little bit. It's a little small. Okay, so I think we could do this, comma. Just to force it into being like a little bit more, a little bit larger, a little bit user-friendly compared to what we have now. See if this works. Hopefully, fingers crossed. Yes, we have something nice. So now you can see visually the United States and the clusters. These are all cluster 3, right? So based on consumer spending behavior, all of these clusters are the same. So if you have a customer base in, let's say, Montana and Idaho, and you know these other states for North Dakota, South Dakota, Nebraska, Colorado are similar in terms of customer behavior, customer spending behavior or customer spending patterns, you can easily expand into these 4 states right here because you know you already operate in Montana and Idaho, Colorado, North Dakota, South Dakota, and Nebraska are the same as is Kansas, as Oklahoma, and so on and so forth. New Mexico, these states down here, I don't have to name everyone, right? These states are similar in terms of spending behavior. These are similar in terms of spending behavior. If you operate in Washington, you want to expand into Utah or Arizona based on consumer spending behavior, you should be able to do that pretty easily. You should be able to move into Arkansas, Illinois, what else? Massachusetts and New Hampshire pretty easily based on the K-means construct, or the way the K-means algorithm, K-means clustering is done. So this is density-based scanning. You can look this up online. It gets a little complex. I'm not going to go into all the details, but it's a different technique for doing scanning. So according to this algorithm, Maryland, Michigan, and Illinois are the same, and all the other states are similar, but dissimilar from these 4. And then if you use agglomerative clustering, you have 4 different clusters. So these states are similar, these are similar, right? Anything cluster 0 is the same, cluster 2 is the same. This is cluster 1, and this is cluster 2. So you have 0, 1, 2, and then we should have a 3 over here somewhere. Where's the 3? Oh, I don't see it. So maybe we have 0, 1, 2. Yeah, we don't have a 3 actually. So that's fine. So agglomerative clustering couldn't pick a 3rd, and that's fine. It is what it is. So let me cut this out. I was testing something. I actually don't need that. But let's say we want to look at a subset of data, because if you were paying attention here, we're looking at clustering for everything, right? So if I go back over here, yes, here, and we are going to scale all the features. So this is the data frame states. That comes from over here, and all the features comes from here. Control F, features comes from features. This is data frame states columns, okay? So anything that is not excluded, we're not looking at the excluded items right here. This is data frame states. So again, we're filtering out the United States and those regions, New England to the far west, all those regions are gone, and we're looking at everything else. So total PCE, durables, right? We have 4 durables: durable motor vehicle, durable furnishing, durable recreation, durable other, and then non-durable food, beverage, non-durable clothing, non-durable gas, energy, and non-durable other. So in the first example I just showed you, we're looking at everything, the whole universe, the whole population of everything. But what if you say you just want to look at durables and non-durables, right? And you want to take a subset of this data, you can easily do that and still do the clustering exercise, right? So Control Enter to run the cell. We'll see kind of what we saw before. Here's the clustering for KMeans, DBSCAN, and agglomerative clustering, right? We're going to take all those and append that into the original data frame and rename the columns relative to the different clustering techniques that we're using. Okay, so we're doing that for the durable side, and then we're doing the same thing for the non-durable side. So we do durables. This is what it looks like. Let me get these charts blown up just a bit. I think it's a little bit easier. Just a tad bit easier with, I have to spell it right, a little bit easier just to look at, visually more appealing, I think. And then get this thing over here, comma, okay, enter, comma, enter, and then control enter to run. We'll get the maps back. Okay, that looks good, that looks good. Let me put that down here too. Oh, just slightly better looking, I think. In my opinion, that's my 2 cents. Control enter to run that. Okay, so now we're separating the durables and non-durables. I'll explain in just a minute why that might work better for you. So you can see all these states are similar. Anything that goes in cluster 3 is the same. Here's cluster 1, here's 2. We should have cluster 0 over here. Okay, so these darker states are cluster 0. And you can see on the chart, or now what this is called, the key or the chart, or whatever, like I forgot the name of the thing. Okay, anyways, the darker the color represents that clustering, and the lighter the color represents that other clustering. So here's the 3s as yellows, here's the 2s as green, the 0 is dark blue or purple, something like that, and then the 1 would be like kind of a dark blue color. So here we have the K-means, we have the DBSCAN, right? DBSCAN is kind of a different technique. It's density-based scanning, so it's clustering 5 states together, right? It only has 2 clusters, so this is -1, and all the others are 0. So we have -1 and 0. The agglomerative is a little bit closer to the K-means, where these states are similar. So here we have cluster 3, here's 0, here's 1, and at some point we should have a 2 in here somewhere. Not seeing it right now, but I should have a 2. That's kind of a brownish. Oh, there's a 2. Okay. So those are the durable goods. Okay, hopefully that makes sense. Now I want to focus on the non-durables, right? So we're picking these non-durable columns, excluding the durables, and excluding anything that is geographically based or geographical, like a summary of these states, right? These would be the regions. Okay, I guess these would be called regions. And then we're looking at non-durables. Control enter to run the cell. Similar technique as before. All I'm doing is changing the columns, right? I actually called it durable columns. It should be non-durable. Let me see where this is going. Durable columns. This is non. Change the name just to make it more representative of what we're actually doing. Control enter to run. And we'll see the mapping. And again, here's the K-means results. So these are similar in terms of the non-durables, right? Anything over here, cluster 1 is similar. This is 0, this is 2, and we should see a 3 at some point. I don't see any yellows. I guess we only have 3 clusters at this point. Here's the DBSCAN. So Massachusetts is off by itself. All the others are clustered together. But again, like, you have to be careful with this DBSCAN. It's looking at density-based scanning, so that might be appropriate for your needs. It might not be appropriate. I'm just showing you 3 different clustering techniques. There's, I guess, a dozen different methodologies that you can consider using, and it might be worthwhile to go through all 12 of those guys. I'm just showcasing 3 right here and showing you what the results are. So this is 0, this is 0, this is 2, this is 1, and we should have a 3, I think. Maybe not. Maybe we don't have 3 because we don't have any yellows. So that's fine. So we only end up with 3 clusters at this point. So going down here in my notes, and I'm showing you where I got the data from, right? To get this exact data source, I think is important too, so you can follow along with this example here. Control enter to run it. This was the source of the data. And I think I just picked this Excel file. Wow, where did it come from? Interactive data. And I think this is it. Let me see. Let me just double check this to make sure. Or is it this one right here? Sorry. So let me figure out per capita consumption. Maybe this was the one. Okay, give me a second because I want to make sure that we get the right data here too. Maybe this one. Or was that in my notes or not? I just went to here. Okay, I'll make sure this is right. And then I think this was it. But why am I not seeing the file? That was it. That was weird. Oh, here. I think this was it. Oh, I think so. Let's see. Yeah, table 2. Okay, so actually it comes from that website, and then this funky looking thing over here that has all these merged cells and everything, right? Okay, so it actually comes from here. So let me just put that in there. And I think I had that reference at the beginning too. Go back here. Yeah, that's it. Okay, so okay, we're good now. Okay. So everything looks like it's on the up and up. We did all of our clustering. Okay, and just to summarize here, basically we are doing the overall clustering holistically, right? The whole universe is being clustered. That might be the best approach for you. Or you can take a subset, durables or non-durables, or any kind of subset that you can define. That might be more appropriate for you. So basically the takeaway here is use all columns for broad segmentation, right? Don't do the subset if you want to look at everything holistically. Use the durables or non-durable subset to analyze behavior based on category. So if your clustering has to be based on the categorical information that you're looking at, then you have to take a subset that's more appropriate than looking at the whole universe. But it really depends on what you're trying to achieve, right? Like there's a few different ways to do this clustering. Cluster everything together or just cluster a few things together, depending on what you're trying to accomplish, right? So you have to keep that in mind. The analysis is slightly different. The outcome is slightly different, but it's not completely, totally, utterly different. It's a little bit different. It's not completely backwards or something. Like it's still going to make sense. It's still going to work out, but you should, use that lens and understand, are you looking at everything together or you just want a subset of categories, okay? Or you can even use ratios, changes over time and do clustering based on that. It really depends on what you're trying to accomplish. I tried to showcase a few different scenarios here. I think everything worked out totally fine. Your use case might be slightly different, but just keep that in mind. Like you have to understand what you're trying to accomplish and then take the right measures to get there, to get over that goal line, to get over the finish line there. But the approach could be slightly different depending on what you're trying to do. Just keep that in the back of your mind. So that's it, guys. I'm going to wrap this up. This video went for almost half an hour, almost 30 minutes we hit. But I think touched on all the main points here. Good overview of clustering, how to implement this, and how to use clustering to understand your consumer base, right? And based on consumer spending overall, if you were trying to expand into a new market or a new state, and you have operations in an existing state and the consumer spending is similar in one state where you're already successful, now you know where to go into different states and be equally successful in those other markets that you haven't explored yet, but the consumer spending is essentially the same. So if you're successful in Massachusetts and New Hampshire and Vermont are in the same cluster, you'll be fine expanding into those new states. If the cluster is Massachusetts and California and Louisiana, now you can expand into California and Louisiana pretty seamlessly and understand that consumer spending is similar in these states. But you have to do the exercise and run these experiments and see what the outcome is, because it's impossible to determine before you do this. You can't just randomly say, okay, I'm successful in Massachusetts, I will also be successful in Connecticut and Rhode Island. These states are close to each other, but based on consumer spending, you might fail in Rhode Island and in Connecticut, even though you're successful in Massachusetts, right? It really depends where your customer base is and the overall spending patterns of people in those different states, right? That's the main takeaway here. So I'm going to wrap it up. Thanks for your time and attention. Really appreciate it for you watching this video all the way to the end. I'm going to wrap it up here. I'll see you again when I post the next video. which is going to drop very soon. So keep an eye out for that. Thanks, guys. Take care. Bye.